So on an average, the R&D spend of pharmaceutical industry is about $50 billion plus. Cost of drug development, each drug which comes to the market has an average cost of $3 billion in its development. From the time the molecule is discovered till such time it is commercially launched in the market, the average lead time is over 10 years. Typically, pharma companies spend about 10 to 20% of their revenue on their R&D budgets each year. Only 12% of the drugs which from the time of molecule discovery actually get launched in the market. So that means that 88% drugs during some stage of the clinical trials eventually gets rejected. Commercially, only 20% of the drugs are able to recover the costs incurred on their development during the post-marketing stage. It's a highly regulated industry, so on an average, close to $3.75 billion is what pharma companies pay each year to the regulatory authority for various non-compliances to the standards. And as we speak, there are 7,000 plus medicines which are under development. Now this project was done in our pharmacovigilance offering, where we serve number of customers, and so basically what is pharmacovigilance? Let me explain. If one goes to a doctor and doctor prescribes a medicine, and as a result the medicine creates an adverse reaction in terms of vomiting, nausea, allergy, rash, anything. So as a regulatory mandate, this has to be fed back to the physician or to company authorized call centers, data collection centers, so that this information or adverse reaction is processed, analyzed, and information is fed back to the regulatory authority. So where does TCS come in? We gather, analyze, and process this information. Now each adverse reaction would be called a case, and each case would have around 100 plus CTQs at times, 100 plus fields to be analyzed and entered into the client system so that it is submittable to the regulatory. So we analyze this information and we process it, we submit it to the regulatory. Now what does the regulatory authority and the pharma company, how this information is used by them? They periodically analyze this information to see whether there is a need to change or alter any guideline, prescriptive guideline for the drug. Is there a need to add any caveat to the label of the drug, or in extreme cases is there a need to withdraw the drug from the market? Now pharmacovigilance happens in two stages. One, when it is in clinical trials, the drug is still under development. In that case, the composition or the drug composition even can get changed depending on what adverse reactions are coming to the target population. And this is also done when the drug is commercially available, launched in the market, it is being regularly consumed by the patients. In that case, it is to monitor the effectiveness of the drug on the larger population. So in case there is a need to withdraw it from the market because it is causing some side effects or some adverse reactions, then it can be, the regulatory may mandate the company to withdraw the drug from the market, leading to huge financial impact on the business bottom line. So being a regulatory environment, accurate and timely processing of this information is clearly a business imperative, or it can lead to millions of losses to the pharma companies that are our customers. So I will now hand it over to Dr. Deepa to take you forward in this presentation.
Hello everybody. Our process, which has over 560 plus associates, were not performing as per the client expectation, and they were performing at an average error rate of 11.38% as against the customer expectation of 10%. The case level accuracy is checked on a daily basis with a sample size of 15%. The data collected over a period of 4 months showed that the data is normal with a standard deviation of 2.64. However, the process is incapable with a Z-bench value of -0.52. In order to understand why this team comprising of doctors, B-Pharms, M-Pharms were making these errors, we had a brainstorming session with all the relevant stakeholders, including the floor SMEs, the client SMEs, quality reviewers, team members, delivery managers, and we came up with 21 potential causes due to which these errors would have been caused. With a cause and effect matrix, we shortlisted them to 13 potential causes for which the data had to be collected. Now during this brainstorming session, we also came up with few quick wins. One of the issue which the associates would face was that due to a technical issue, the cases would get locked, and then they would have to get in touch with the IT personnel to unlock the case. This would take around 40-45 minutes and also would cause a hampering in the case processing flow. So as a solution, select few associates were trained on the case unlock activity, and this issue was resolved that they would be able to unlock the case within 2 to 3 minutes, thus saving the time of the associates and also preventing the flow, the break which was happening during the case processing. Case allocation pattern was also tweaked in such a manner that highly complex cases were received by the associates during a particular day of the time when they had sufficient time to process them. In interest of time, I will cover only few of the statistical tests. Scatterplot validated that volume of follow-up cases has a direct positive correlation with error rate. Now, in order to give you a short background about what is initial cases and follow-up cases, the first time whenever an information is received about a patient, it is called an initial case. For example, if the patient suffers from high blood pressure and is admitted to the hospital, this needs to be clinically analyzed and processed into the database and submitted to regulatory. That becomes the initial versions. After 5 days, the hospital again sends a report that the patient is better and has been discharged. This again needs to be processed in the database and submitted to regulatory. So this becomes a follow-up version, and the follow-up versions may go up to numbers of 30 or 40. Case source, as if you recollect, it was covered by Saurabh that there are various case sources. The cases which are received during clinical trial are clinical cases. The ones which are obtained after the drug is marketed and freely available in the chemist and other pharmaceuticals, they are spontaneous cases. Then there are literature cases which are received from health magazines, articles, health journals. So with ANOVA, we validated that literature study and literature non-interventional case types are critical factors. Case type, again, with the 2-sample t-test, we validated that follow-up error rate was higher than that of initial error rate. Tenure of the associates. Now, this was one of the most astounding factors of this process. Usually we see that higher the tenure, better the quality, and better the processing of the associates. But contrary to the popular belief in this particular process, the tenure of the higher tenured associates, the 18 plus months and 24 plus months, were the ones who were making more errors. Out of the 13 potential causes, we validated 7 causes. Moving to the solutioning aspect, follow-up cases. It was noticed in follow-up cases that there was a technical issue and there was a bug due to which the information in the case in the initial versions were not getting incorporated in the follow-up versions. So as a result, there were many blank fields. This was notified to the client, and on our recommendation, client agreed to fix this bug and upgrade the software to the higher version. Validation steps were put in place for case initiators and for case processors. Another process design was suggested, however, due to some technical issues, this could not be implemented. 24 plus months tenured associates. As we observed, the higher tenured associates were the ones who were making critical errors. Complacency, boredom doing the repeated kind of transactions, whatever. In order to address that, we developed a churn option by partnering with the HR, and the ones who were capable were promoted to trainer and SME roles, and other aspirant associates were moved to other clinical research domains within the organization, thus preserving the knowledge pool within the organization. For 18 plus months associates, quarterly workshops were organized. An automated training and compliance tool was deployed in order to monitor the compliance of the training of these associates. For high error in teams, eFlow, which was an internal quality tracking tool, was deployed for daily monitoring purpose. This tool would give trend analysis on associate basis, team-wise, group-wise, and also based on errors, which was showcased to the associates on daily basis by their managers. A team realignment was done. So alignment of teams was done on therapeutic areas. So therapeutic areas are basically, excuse me, earlier what would happen was processor would process cases of cancer drugs, infectious drug, autoimmunology drugs. However, the teams were aligned in such a way that a group of associates would only perform or process the cases for cancer drug or exclusively for infectious drugs. Also, star performers were allocated to every team as role models. Now, for literature source type contributing to high errors, as mentioned earlier, literature cases are received from health articles and journals. So usually the authors mention about a population of patients. For example, 30 to 300 patients suffered from nausea after consuming drug ABC, and then the article would follow. So initially what would happen was the cases would be split into these 300 odd cases, and then they would be quality reviewed. But the process design was changed in such a manner that the base case would be quality reviewed first, followed by a splitting up of these cases. For high error contributing associates and drugs, drug-specific therapeutic trainings were conducted. Now, being in the service industry, training and constant learning is a business imperative which we cannot do without. However, monitoring these trainings by training compliance tool was something which we looked into. Also, in order to gauge the understanding of these associates, we deployed online assessment tools in the form of MindWorks auto assessment tools. Training modules were enriched in collaboration with the client SMEs. Do's and don'ts and new scenarios and specific scenarios were included in these SOPs. Configuration of automatic system validations, which had more than 10 plus business validation rules. These served as Pokayuk. For example, if the case consists is of pregnancy case and the gender is selected as male, then the system would throw up an error that the gender is incorrect, and then the associate would have to correct it as female if the case needs to be proceeded with. Also, system query listings, which were a kind of hygiene listings, were run in the system. In case of any inconsistencies, a mail notification would be thrown up to the associate. Example of the case is an overdose case and the radio button for overdose is not selected, then a notification goes to the associate to correct it. This is a snapshot of the training tool. Also, it helps in record archival of the systems. This is a snapshot of the eFlow daily quality reports. One of the most amazing feature of this eFlow quality tool is auto feedback systems on real-time basis per case. This is the system validations which we put in place, and the MindWorks quiz, which gives a trend analysis of the associate scores. Based on prioritization, the solutions were implemented. The improvements were validated by 2-sample t-test and box plot. We can see that the improvement has been quite measurable. The percentage error rate improved from 11.38 to 7.11, which is a 38% improvement. The standard deviation improved from 2.64 to 2.07, which is a 23% improvement. The process capability improved from negative 0.17 to 0.46, which is a 0.64 improvement. The sigma shifted from negative 0.52 to 1.39, which is a 1.91 sigma improvement. The rework reduction created an additional capacity for processing more volumes, which generated savings of $1+ million to TCS. This shows the controls within the process. The out of control points are due to high backlog of cases following bank holiday covers. The sustain plan was put in place. However, the sustenance, since all the solutions were system developed, policy changes, configuration changes in the client software, SOP changes in a regulatory environment, these sustained actions were maintained. Also, this tested our change management skills a lot, because in a regulated environment, for any changes to take place in a client SOP or a client system, there are various approvals which need to take in place. So we had to undergo many sessions and negotiations and discussions with the client to bring about these changes. This project was highly endorsed by the customer and also appreciated by the managers in life science domain. For the advantage of the audience, we have put the latest control chart, which shows that the project has sustained 6 months even after the project was handed over to the process. The benefits out of the project are, this has mitigated the business risk for the client. It has improved the regulatory compliance. It has prevented the toxic environment being released into the environment post, if in case any drug needs to be withdrawn and incinerated. The beautiful piece is that TCS has around 6 accounts in this offering, with 2,000+ associates working, and more than 600K cases are processed on a yearly basis. Thus, the replication has been, we are in progress in the replication across various accounts. Other than these tangible benefits, with a deep conviction, I can say that this project will benefit the future generations, because the drugs which are under development now will be released into the market 5 to 7 years down the line, and it will come out with correct prescriptive guidelines, labeling instructions, and dosage instructions. Thus, I can proudly say that this project is benefiting the society and the future generations to come. Thank you, and we are open for any questions now.
So Vinay, if there are any questions, you can.
We'll wait for another 5 minutes.
Yeah.
Yeah. Saurabh, if you can take us back to the 2T sample testing.
Okay. Yeah.
Yeah, participants are asking for, to explain this.
Okay. Follow-up error rate and.
Yeah, as I was mentioning, initial cases are the ones which are received for the first time. So, and follow-up cases are the ones which are received after the first version is closed. So, we categorized it into two types of cases, the initial versions and the follow-up versions, and also derived an error rate for both. And in order to understand if there is a difference between the mean error rate of follow-up cases and mean error of initial cases, we did a two-sample retest, and we found that yes, there is a difference in the mean error rate. Follow-up error rate was high at a mean of 13.5 and initial error rate was at 9.30. So this helped us to further analyze the causes why the follow-up error rate might have been high.
May I know if anybody has question to ask?
Hello, Saurabh.
Hello, yes, please go ahead.
Yeah, yeah. Okay. We'll wait for another 5 minutes. If anyone has a question, they can ask. Then we can go for the KSPG case study.
All right, all right.
Saurabh? Hello?
Yes, please.
Yeah, there is a question from Vamshi Krishna.
Yeah.
Can you explain cause and effect matrix once again to understand how causes are prioritized?
All right. So,
Yeah, so there was a ranking given to each of these causes, and these rankings were given after discussion with the stakeholders. And based on the ranking, we shortlisted the ones for which we would collect the data.
so whatever came in fishbone went through this cause and effect matrix, again a brainstorming exercise. The team jointly put together the score in terms of what would be the impact on error rate of each of these causes. And basis that we prioritized on what all excess should we go ahead and collect data on. So from 21, it was reduced to 13 axes on which we collected data and statistically validated for significant factors.
I hope the answer is clear. Participants can key in their questions in the right hand side. There is one arrow mark where you can find the question dialog box. You can type in your questions and I will speak about it. I hope that those are the only questions from the participants. Thank you, Deepa and Saurabh Gautam, for your wonderful presentation. Now I'm switching over to KSPG's presentation. The presentation is done by Anand Mishra. Thanks, Saurabh. Thanks a lot.
Yeah, thank you.
Thanks, Vinay.
Mr. Anand?
Yeah,
Yeah, we are able to see your presentation.
yeah, you can see. Okay, it's okay.
Yes, yes. Yeah, yeah.
Just
you can
a minute.
start. Yeah.
Just a minute. Yeah, hello everyone. Good afternoon, and I am Anand Kumar Mishra, and with me my colleague Mr. Magesh Yadav, and we are presenting today our case study for project on quality improvement of SCGR line. Just a minute. This is my team. So whenever we have done this project, this team has involved Neeraj Negi, CI coordinator, and myself, Anand Mishra, production manager, and with me, Santosh Vankati, production supervisor. And, this is our plant, different type of product we are making for car product and our site worldwide. This is our product, whatever we are making in the Takwe plant in Pune, and this plant we have started in 2008 for construction, and we have started production readiness in 2009. This is our certificate, whatever we have taken from our customer, Ford, General Motor, Nissan, Fiat. This is our BE Mechatronics organization structure. So every year we are just taking audit. So you can see this is our audit plan. This is our business excellence building. So as
Anand,
yes, please.
Yeah, if you can enlarge it, you can press F5.
Yeah, just a minute.
You can put it on.
F5.
Yeah, this one. That's right. Yeah, presentation.
Presentation.
Yeah.
Otherwise, it's very clear. Please go on.
Now it is okay.
Yes.
Yeah. So this is our business excellence house. So there are you can see our BSM 5S and external problem solving and visual management is our base, and then we are using Lean Six Sigma TPM. And as per through we are prioritize our project. So this is our project, whatever we have prioritized in 2015. So first there are quality improvement project. So you can see in our first prioritization. Through BSM we have done in that line, SCGR line, and you have seen there have our SCGR line is very critical for FTQ. So FTQ is approximately 92.9% and other line is more than 97%. So we have give more focus on for quality improvement at SCGR line. And you can also see as the Pareto chart, there have given station 40 hull tipper leakage issues. So the major reaction at that line. Our baseline in 2014 is 7.08. After that we have started this project in 2015. So that time current current reaction rate is 5.02. After that we have project taken. So our target is 0.5 we have taken, and you can see behind of our project charter here, and also our time plan. This is our project, how to work in that. So major is this project name is EGR, so exhaust gas recirculation. So basically we are saving our protect our environment through NOx and whatever exhaust, carbon dioxide, NOx, acid, and carbon dioxide also. So our major problem is leakage issues. So we are giving pressure 0.5 bar from this side as a fixture, and we have leakage problem from both wall taper. So this is our operation. So operation first one, you can see there first wall taper placing and crimping operation here. After that second wall taper crimping pressing. Then we are here leak testing. So first wall taper sit here, second wall taper here is set. After that we have taken leakage value. So you can see there have some few parts rejection due to not auto specification. After that we have done gauge R&R, MSA analysis. So as per gauge R&R, we have found okay, because the total gauge R&R is 4.43% only. Then we have moved to fishbone diagram. We have involved whole team, machine operator, industrial learning and quality team with production supervisor also. And after that we have identified 32 causes, potential causes with team. Then we have done voting process, and we have multiple voting. We have found out major 5 causes. So for work starting first now after as per prioritization. Here is first our causes is spring stiffness, not okay. As per our team session, so we have started work on spring stiffness, not okay. And you can see here as per spring stiffness force versus leak test. So Magesh will be explained you better there.
For the cause number 1, the spring stiffness, that is the force of spring, is the required value is 20 plus minus 0.5 Newton, and against that we checked leakage. So to identify whether the cause is significant or not, we used the simple linear regression, because our y is continuous and x is continuous, and the results are, we have the p value is 0.859, that is the value is more than 0.05, so the spring stiffness is not a cause for the leakage. Our second cause is again the housing runout, where the wallpaper sits and around which we are checking the leak value. So our housing runout, again the x is in continuous mode, so we done multiple regression and check the relationship with the leakage problem. The results are again the p values are more than the 0.05, and the runout is not a cause for the leakage. The next cause, that is the third cause we've concluded during fishbone, is problem in shaft, that is the parts, the first wallpaper and second wallpaper. These are the parts assembled during the wall assembly, and through which we are checking the leakage. So for the all these 3 parts, we have supply from 2 suppliers. One is from Mani, that is the local supplier from India, and another is from this Microdeco, that is the imported supplier. So we decided to study all 3 parts for the contribution against leakage. Again, for this part analysis, we done DOA study, and the results are for the shaft. The p value is again above 0.05, that is no significant effect for the leakage. Then we found the significant effect from the parts, that is first wallpaper and second wallpaper. And you can see the p value for first wallpaper is 0.011 and the second wallpaper is 0.01. Also the R square, that is the relationship or the relation with the problem, is 82.04%. that is very good model to correlate with the problem. So after finding out the problematic parts for the leak test, as there is 2 suppliers for the same part, and we need to decide whether part problem is from both the suppliers or single supplier. We analysis done for both the supplier, and the conclusion here you can see for the shaft from supplier A, that is Mani, and supplier B, that is Microdeco, there is no major effect to the leakage value. Leak value is shown vertically. Then again for the second component, first wall taper. So the first for supplier A, that is many, the leak value is little bit higher, and the second supplier, that is supplier B, Microdeco, the leak value is at the lower side. Same thing for the second wall taper, that is the second part, assembly part. Supplier A, the leak value showing at the higher limits, and for supplier B, the leak value shows to the lower limits. So the conclusion is supplier A, that is many wall taper, contributes to the leakage. So here is the causes and the conclusion. So during our fishbone, we identified 5 top causes. First cause is spring stiffness, and it is proved that there is no significant difference of spring stiffness on leakage. Second one is housing runout, that is also no significant difference. Then again third one is the shaft, the part goes during the assembly. This is also not the contributing factor. The last two causes, that is cause number 4 and cause number 5, the parts wall taper 1 and wall taper 2 are the contributing factors for the leakage problem. And in detail, if you check the leakage, the parts coming from 2 suppliers, and the supplier A is the major contributor for the problem. It means that is the root cause for our leak problem. So we decided to do the dimensional comparison for both the suppliers, and here you can see in box plot the dimensional comparison in supplier A and supplier B. We checked the wall taper runout, wall taper runout which matches with our housing surface, and if the matching is not good, there will be leakage from this round profile, that is the runout of wall taper. So we compared supplier A and supplier B for the runout, and in box plot you can see the supplier A, there is more variation and the leak value is at upper side. In supplier B, the variation is lesser. So again, to find out the runout, why the runout is higher in supplier A, we visited to the supplier. So our supplier is many in Bangalore. So we did YY analysis with at the supplier end with their team, the operators and the production supervisors. And the YY analysis is why the wall taper runout observed. So the second Y is due to improper clamping pressure, the clamping pressure of the machine during machining. And third Y is clamping pressure range. We found it is from 3 to 10 setted on the machine. The range is very big as it is from 3 to 10. So we decided that the last Y, we concluded the last Y is process parameter validation not done, because the pressure value is pressure specification is too big. So we decided to optimize and validate the process parameters. So we selected the process parameters for the machine is clamping pressure, feed and speed. So again we did the analysis for this clamping pressure, feed and speed. You can see the factorial regression for that clamping pressure, speed and feed. And again the p-values indicates that the speed and feed is not the significant cause. The only significant cause is clamping pressure, which contributes to the problem of runout on the wall taper, and that runout variation contributes the leakage to our wall. So with this effect plot, you can see clearly the results that the clamping pressure for the runout varies with the varying clamping pressure, and you can conclude that this clamping pressure, if we select the clamping pressure is 4 to 5 bar, then we can get more better results other than other settings. Also the feed and speed, we have no major difference. So we concluded that the best setting parameters for clamping pressure, we decided 4 and 5. Again, to control this clamping pressure, that is high chuck clamping pressure, implemented POCA-AK so that there will be no variation during mass production. And the POCA-AK is we did interlocking for this clamping pressure with the machine PLC, so that whenever there is a variation, the set clamping pressure from 4 to 5 bar, if it goes beyond the lower limit or higher limit, it will show the error message on machine screen and machine will get stopped. Again, after improvement and the POCA-AK implementation, we checked the variation for this runout from supplier A for the wall taper, and the data is as shows. Before the runout is having more variation, and after improvement, that is clamping pressure improvement and POCA-AK implementation, we found the runout variation is reduced. To validate the improvement and the significant cause for the leak test, we did 2 sample T tests. You can see the results for 2 sample T tests. The p-value is 0.0. That is, whatever improvement we implemented at supplier end is significant, and the improvement in the runout is also significant. This is the eye chart for the controlling the runout values at supplier end after improvement, and all the values shown in the chart, or we can see all the values for runout is well within the specification. After all improvements at our end, that is our SCGR assembly line, you can see the leak test improvement week wise, that is from week 19 to week 28, and you can also see the before and during improvement what are the stages and the leakage percentage. So ultimately we got the leak percentage, that is improvement percentage, up to 0.14. These are our savings after completing the project, and the total saving of the project is 34,46,264. The savings are validated by our finance department by calculations of MST and the line cost. In our company, we are following the CII database, that is continual improvement database. This database is common for all our worldwide plants, and the project is updated in the system so that our other plants can refer the project for their problems if the similar problems at their end. These are the documents updated during the project and after the improvement to sustain the improvement and to sustain the leak improvement in the leak value and the FTQ. So we updated our CII database, which is anyone can see for the improvement. Then control chart, then again control chart and POCA-AK at the supplier end, then FMEA, the RPM number is updated, then control plan and the reaction plan for the leakage. This is the project summary. As you can see, the leakage percentage is reduced from 5 to 0.5%, and in project summary again we have the Pareto for the problem, then we done MSA, then we have the fishbone diagram, then we did DOE studies for the part analysis, and then comparison with two suppliers, improvement at the supplier end, and then control and achievement of the reduction from 0.502 to 0.14% for the leak value. Lesson learned from the project is this importance of the DMAC phases and use of statistical tools in finding the exact root cause and getting the results. Thanks to all. Any questions?
Thank you all.
Anand,
Yeah.
if you can take us back to the Poke, you can just explain.
This one?
Not this one. Yeah, this one.
You can see the earlier there have the pressure bar is 10 bar, okay, clamping pressure, and after that we have modified pressure check, and you can see there have 4.5. Okay, so for 2 bar we have given their specification, earlier that 10.
Okay. And what is the next slide shows?
Yeah. Here we have done Poke through PLC, and if more than 5 bar clamping pressure will be set, after that time check pressure, high pressure will become alarm and machine will be stopped. Same thing, if less than 4 bar, then check low pressure will be low, that alarm will become and machine will be stopped. If they have 4 to 5 bar, no alarm, and machine can be run continue. That is their Poke.
For which gauge R&R was done? A question from Sri Krishna.
Yes.
Gauge R&R is done for the leak testing. Leak testing unit is on our leak testing bench, and the test bench is including the fixture for the part mounting, and the total system through which we are checking the leakage. That means the leak testing machine, that is attack unit, ATQE unit, with the fixture setup. So all this fixture and the leak test unit, we done MSA for both.
There's one more question. Are we getting the value tampers from supplier Mini recently, or from day one of now?
Actually, from not day one that problem has came. After 6 or 7 month production has started. After that, we have seen our leakage value has started. Reaction has started at line. Then we have started that part is checking. That's why we are finding. Not for day one.
Okay, one more question. The dimension runout was not inspected at IQA. In the sense like incoming inspection, where specification to supplier were revised after improvements.
Earlier we have random check because of this line is volume across. We are making 40,000 parts per month, so we are checking randomly 5 pieces per lot. Okay, and that cannot be possible to every time. Can be find out in the first time. Now we are added in our receiving inspection. They are checking now because of we have also added control chart.
These specifications were improved later?
Yeah.
Okay.
Because we had two supplier, so you can see one supplier A is okay, Metrodec is okay, but we have problem with many. So both parts is running in line and not able to find out first time which part is coming. So after that we have started project.
Okay. There's a question from Omshi Krishna. What is the reason to go with the local suppliers?
Localization is always low cost.
Low cost.
Yeah.
Now, what about the supplier Microdec? Microdec supplier. What about the Microdec supplier?
Yeah, that part is okay. They have no any issues. So you can see in this chart, they have no variation
Which chart?
within 15 yeah, now at my desktop.
Okay. Okay. Run out.
Here variation is within 15 micron and drawing tolerance is 30 micron. Right? So within 15 micron they are making.
Okay. Hope it is clear to Omshi Krishna regarding why they have went for the local supplier. Anand,
Yeah.
at the time of supplier selection, was the process validation not the part of audit scope?
Yeah, PPAP have done, but you can see there have a big parameter given for process, parameter for clamping pressure, right? So as per clamping pressure, whatever he has set, that time values, we have PPAP done, but that time process validation has not done. That's why this problem has can passed. Just a minute. Yeah, clamping pressure is there earlier that 2 to 10 bar. So maybe that time when PPAP have done, process parameter has to set to 4 to 5 bar. And you can see also when we are doing PPAP, that is not more than 300 parts. And now we are making 40,000 parts. So variation is increased.
Shashank, if you have any question, you can ask. You have written one question. Shashikala is not.
Hello, hi, Shashank here. I was just listening to the okay, which you explained. I think it's just an opinion. It's a visual control basically. When the pressure goes out of the limit, it is warning you. It's a visual control or visual warning signal. Whereas you are not exactly removing the, you are not mistake proofing it by reducing the fluctuations of the pressure. Below 4 bar or above 5 bar. I mean, it's a visual control. The mistake is not foolproof. What I just an
Actually,
opinion.
there is no visual control. The pressure limits are interlinked with the PLC of machine. Just like whenever we are connecting machine to the air pressure, if the air pressure drops, machine automatically shut down and shows that the air pressure is low. Similarly, the pressure limits, that is 4 to 5 bar, is linked with the machine PLC, and whenever there is out of specification or out of, it
I
will
missed this
shut
at
down.
machine shutdown. Okay. Machine shutdowns. Okay. Thanks.
Yeah,
Yeah.
this one is the CNC machine, so that control through PLC.
Okay. I just missed on that because I just thought an alarm will blow up. I didn't know the machine would shut. Okay.
Okay.
चेक करत होतो वर्क होतो म्हणजे इन्शुअर म्हणजे ह्याचं व्हॅलिडेशन पण पाहिजे. हा मग ते त्याला जर लिहिलं की तो म्हणे आपलं बोलणं जातं की म्यूट करतोय अनम्यूट करतोय. So let's show your standardization slide. दाखवली होती नाही ना स्टँडर्डायझेशन? नाही आधीचे आहे.
We have got another 5 minutes. If you have any questions, please ask.
No, we don't raise a PO. It has to come from the this regarding this. Take it. Okay. 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 That's okay. We need an email from you.
Thanks, Anand, for your wonderful presentation. We'll wind up for this session. When we'll catch up for the next session, which is from Kirloskar Oil.
Thank you all.
Yeah, thank you. Bye.